Um, so you can stay here for data modeling, or you can do your own thing, or you can decide later. Okay, so at Hackbright, where I used to work, we use this this sort of movie about puppet genocide for data modeling. I don't know if you guys have seen The Dark Crystal, but yes. Yeah. So we could use that, or we could use a project that I'm working on, and I don't know. Either would work. Let's talk about. Oh no, let's just do the Dark Crystal for now. There was recognition on the Dark Crystal. Okay, so here's oh, and let me oh no, I already started recording. Okay, cool. All right. So, here's the situation. Do you guys remember the Dark Crystal? What? Okay, yeah. So there are Gelflings, and there are Podlings, and they are being oppressed by the evil race of Skeksis. I have not seen this movie. I've just given this like data modeling lecture at Hackbright so many times that like I know the basics. Okay. Okay. So, all right, so we've got Gelflings and Podlings and Skeksis. And so Skeksis want to consume essence from these poor Gelflings and Podlings. Gelflings have, I think, maximum like 500 units of essence. I'm just making this up. And Podlings have like 100 units of essence. Podlings, according to one of my colleagues at Hackbright, are basically just socks with a mouth, right? They're really not very, like Gelflings are actually the more human-like, and I think there are only 2 Gelflings left in all of Skeksis land and whatever. Okay, so fine. So the Skeksis, they capture Gelflings and Podlings, and they consume essence. And the questions, and we have been contracted by the Skeksis to create a data model, to create a database that will record all of this. So what they want to be able, these are the questions they want to be able to answer, because that's what we do with databases, is we want to be able to answer questions. So how many prisoners are there? What types are they? Species. How much essence does each prisoner have left? Skeksis are very competitive, so a Skeksis leaderboard for who has consumed the most essence during a period of time. Oh, did I do something that stopped? I don't know what that was. Okay. Where are the prisoners? what cages? Let's see. The podlings and gelflings are dismayed that you're so bored by their plight. Yeah. Yeah, no, yeah. I don't take that personally. Not unlike the podlings and gelflings who. Okay. What other questions do you think that they might want to ask? What questions do you have for what? Yeah, so that we got that here.
Oh, sorry.
No, that's cool. That's cool. Okay. So let's start thinking about our data model here. What tables might we want to have? A gelflings and podlings table. Should they be in the same table or should they have their own table? So we could, for gelflings and podlings, what would be the advantage of separating them out into their own tables?
Are they, I don't think I heard the first part. Two different species.
They are two different species. There are advantages to separating them out.
So they can have like their own specific individual things that are.
Ah, yeah, let's talk about what data do we want to store about the gelflings and podlings?
Maybe their characteristics.
Okay. But that, I think, would be a species table, right? We could have a species table that has the columns are characteristics like max, essence, species name, native habitat, whatever, And then the rows are going to be the individual species. Not an individual podling or gelfling. This table is going to have basically two rows. It's going to have a row for podlings and a row for gelflings. But it's not going to have, so if we want, because you wouldn't want to have to, in your prisoners table, I'm going to make a prisoners table here. In your prisoners table, you would not want to have, it would be wasteful for every prisoner for you to store its max essence, its species name, its native habitat, how do you go to the bathroom in their language, whatever, right? For every prisoner, when all of that stuff is the same depending on their species. So it's much more efficient, it's much more efficient to store what species they are for each individual prisoner. And then in the species table, we can store, information about the species. So in the prisoners table, and we always, by the way, we always need to have a primary key. Every table needs to have a primary key. So the primary key for the species table would be the species ID. Fine. Okay. So for the prisoners, what columns might we have for the prisoners? Yeah, species ID, good. So the species ID is going to be a foreign key. it's going to be the key to, it's going to be an ID that has to be in the, species table. And in order for us to have this foreign, let's see, if we designate this as a foreign key, we get what's called referential integrity. Have you guys heard of that before? Referential integrity means two things. It means I can't add a prisoner with a species ID that doesn't exist in the species table. That would violate referential integrity because this is a foreign key, so it must exist in the species table.
Can you say that again? You can't add it.
So you can't add a prisoner with a species ID that doesn't exist. So let's say some new, essence container was discovered for the Skeksis, and I wanted to make it, and I wanted to add them to the prisoners table, but I hadn't added that to the species table yet. And I'm just like, okay, I'm just going to give it species ID 3. And because I've designated this as a foreign key, basically, SQL is going to say you're not allowed to do that. Species ID 3 doesn't exist in the species table, so that would violate referential integrity. You may not add that until there's actually a species ID 3. And conversely, you can't delete a species row in the species table if something in the prisoners table is referring to it. That would violate referential integrity as well. So if I had a bunch of gelflings that had species ID 1 in the prisoners table, and I wanted to delete the gelfling row in the species table, then I would get an error saying you can't do that. There are prisoners with that species ID. Okay, what else might we want to store about the prisoners? How much essence they have. I am going to put a star next to that one. That brings up another database or data modeling concept called normalization. The question is, do we want to store how much essence they have, or do we want to calculate how much essence they have? Is it going to be possible from other tables to calculate their essence? And if you do store the essence, even though it's calculable in other ways, there are risks to that in that they might get out of sync. What if your program somehow records an essence consumption and it doesn't get updated in the prisoner's table, how much essence the prisoner has? Then you have two answers for how much essence the prisoner has left. One from the prisoner's table and one from all of the essence recording, essence that have been consumed. Sometimes it's okay to take that risk. For example, like in Amazon, when they tell you something is like the #1 bestseller, they are not recalculating that every time somebody goes to a different page, right? That's almost certainly denormalized in the Amazon database, and they calculate that once a day, and it might not agree with some of the other data in the database. Here, and we could talk to our client and ask, but here I think there are going to be few enough prisoners that we probably want to calculate this rather than store it. Yeah, Sabrina. Yeah, so denormalized means that data is stored in that you can get to data in two different ways in your database. So for example, we haven't talked about it yet, but let's say we have a consumptions table. And the consumptions table somehow references the prisoner, and it tells you how much essence was consumed. Then it's possible to calculate how much has been consumed from any individual prisoner by totaling up what's going on from the consumptions table. And if we stored it in the prisoners table, then you could get to that information in two different ways. You could both calculate it from the consumptions table and go to the column in the prisoners table. And it's dangerous because those two ways could get out of sync. If we didn't update how much essence they had in the prisoners table, then we could get two different answers and which one is right. But sometimes it's okay to denormalize data because just as a matter of like speed. If it's a calculation you're going to be doing a lot and there's a ton of data, maybe you want to say it's okay to do that calculation once an hour and have it possibly be behind or different from the data. That's deliberately denormalizing the data. Okay, so I'm going to say we're going to keep our data normalized. We're not going to record how much essence they had. But in order for us to do our calculation with the consumptions table, we do need to know what their initial essence was when they came in. Because they can come in, they don't have to come in with their max essence. They could come in with less than that if they had been drained by Skeksis in the wild before they had been imprisoned. Super cheerful. Okay. Anything else we want to record about prisoners? Thinking about the questions that we wanted to ask here.
Where they are.
Where they are, what cage they're in. How are we going to store that?
Depends on if you remember the cages or not.
Yeah, shall we make a cage table? What else would we store in the cage table? Ah, that's an interesting question. In the cages table, would we store who's in the cage? What would we call that column? If we call it prisoner ID and link it back here, then what happens if there's more than one prisoner in that cage? What? Can you make this a list? It's generally frowned upon. You can, but that's not how databases usually work. But that's a perfectly legitimate question. I could do prisoner ID 1, prisoner ID 2, prisoner ID 3. What's wrong with this? Definitely would be awkward to call. Like if you want to check if somebody is in a cage, you have to check like all the cages and see are they prisoner ID 1 in that cage? No. Are they prisoner ID 2 in that cage? No. Are they prisoner ID 3 in that cage?
Another table inside the cage table.
Oh yeah. Again, like I like what the way you're thinking to make another table. In SQL, you don't have nested tables, but instead, what you do is you make a table called prisoner cages, and this, because the relationship between prisoners to cage. Well, no, actually, no. I take it back. I'm getting ahead of myself. Here, what is the relationship between prisoners to cage? Are prisoners, can one cage have many prisoners? Can one prisoner be in many cages? No. So we have a one-to-many here. And when you have to one-to-many, you do not need to make another table. You just need to put the cage ID, you need to put the many, the ID of the many into the one. We'll get to many in a minute. So what else are we going to have in the cage table? That's a good question. Does the cage have a maximum occupancy? These are magic cages, and they can hold as many prisoners as needed. Good question, though. Why do we need a cage table? Why can't we just put cage number there? Is there an advantage of having a cage table? 2 4-syllable words. Referential integrity.
Oh, syllables. Sorry, I was thinking that.
2 4-letter words. Oh yeah, that's true. Referential integrity. This way we can ensure that we don't put prisoners into cages that don't exist.
That seems like that seems like a data problem, not a real problem. How do you have a prisoner not put them in a cage?
No, you have a prisoner, and let's say by accident, Ethel the Skeksis, who's doing our data entry, puts them in cage 543, and there is no cage 543.
Yeah, that's what I was saying. It's a data problem. It's not a real problem. You can't just have a prisoner and there's a non-existent.
Oh, right. Yes. No. Indeed. But we're solving data problems with our database. Yes. So even though the cage has only one column, it's still useful for referential integrity. Okay. Shall we start on our consumptions table, or is there another table that people would like to do? I'll take that as yes. Let's start on the consumptions table. What columns does it need? Or do people have questions? What columns? You always get the ID for free. You can always just shout out the consumption ID. What else do we need to know? Do you understand what I mean by the consumptions table? It's like whenever a Skeksis goes and consumes essence from a prisoner, we want to record that.
So is this similar to? Actually, I guess it's tied to what would be the leaderboard. It's separate from it.
Yeah, it is. Yeah, exactly. It's going to help us answer that leaderboard question. The essence consumed, right? Yeah, so amount, essence, amount. Great. What else? How are we going to, prisoner ID. And that's going to be a foreign key. Who consumed it? How are we going to know who consumed it?
Probably have to have the table since that would probably be part of the
Okay, so we have to have a schemas table. So, right, so we have this essence amount, and then the leaderboard had a like a period of time. So we'll put a date here. I like to make dates, it's convention to make dates be _at. So consumed at, you know, in our prisoners table, we can have arrived at or captured at. That's a hint that it's a date. All right, so schemas, we'll give them a schemas ID. We'll give them we'll give them a name. What else would we have to do for schemas? Consume today. That would be denormalizing, right? Because we could calculate that from the consumptions table. So we could, if that was an important piece of data that we were going to be retrieving a lot, we could denormalize it. But for now, I'm going to keep that data just as something that I can calculate from the consumptions table. Yeah, I don't think we really need anything else for schemas. Okay, so let's talk about the relationships between the tables. Oh, so wait, first of all, can we answer how many prisoners are there? Yeah, we can get a count on the prisoners table. What species are the prisoners? We can do a count and we could group it by species. How much essence does each prisoner have left? We can do a join on the prisoners and consumptions table to calculate how much essence each prisoner has left. Who has consumed the most essence in a period of time? That would be a join on the schemas and consumptions table. Where are the prisoners? So we have a cage ID in the prisoners table. So I think we're good on answering our questions. Yeah, let's talk about the relationship between the tables, just so we can practice this like sort of one-to-one, one-to-many, many-to-many. Species and prisoners. What's the relationship between species and prisoners? One-to-one, one-to-many, many-to-many. So each species can be associated with many prisoners, and each prisoner can have many species. No, yeah, so that's a way to think about it. So it's going to be one-to-many. Each species, or each prisoner has one species, but each species can be associated with many prisoners. One-to-many, species to prisoners. Prisoners to cages. I want somebody to explain it to me just the same way I explained the species to prisoners. Yeah, Sabrine.
Each cage can have many prisoners.
Uh-huh.
Each prisoner cannot have many.
Can have only one cage. Good. One-to-many. Prisoners to consumptions. Each prisoner can have many consumptions. Each consumption can be associated with many prisoners. Yeah, yeah. One-to-many. Schemas and consumptions? Somebody want to practice saying the words?
So it'd be one-to-many since schemas can have many consumptions, but a consumption can only be done 5.
Yeah, very nice. Very nice. Okay. Do we have any many-to-many relationships in this database?
Do we have one? Don't think so.
No, you got it. I thought I had it in there.
Do we have one between prisoners and schemas?
Ah, we do. Have you done database stuff before? Yeah, we do. Your first instinct would be to say no. We don't have any. We just looked at all the relationships between all the between the tables, and they were all one-to-many. But we do have one between prisoners and schemas. And how can that be when the schemas don't have a prisoner ID and the prisoners don't have a schemas ID? They don't seem to be related at all. But many-to-many always has to go through another table. Many-to-many always has to go through another table. So, and the table that we're going through is the consumptions table. Each prisoner can be consumed by many schemas, and each schemas can consume many prisoners. So again, let's say we're talking about, just to give another example of many-to-many, because many-to-many is the hardest one to understand. If we had a film, like a film ratings thing, we'd have users, we'd have films, and we'd have ratings. What would the relationships be between these three tables? So somebody just throw one out. One film would have many ratings, one-to-many. Each rating has only one film.
Users could give many ratings.
Users could give many ratings. Each rating has only one user, we're assuming in this model, one-to-many ratings to users. Do users and films have a relationship?
Yes.
What is it?
Users can watch films.
And
And many films can watch one.
you just said the same thing again.
Yeah.
Users can watch many films.
And each film will be watched by many.
Each film will be watched by many users. Many-to-many. And that they are joined, they are associated by this ratings table. The two association tables that we've talked about so far, this ratings and this consumptions table, they have additional information, right? The consumptions tells you the amount and the date. The ratings table tells you what the user thought of the film. It's also possible to have these association tables have no data of their own. Their sole purpose in life is to join to other tables. So you can think of books and genres. That's sort of a classic example. Yeah, so the tables, the association tables that we have now for our many-to-many, both the ratings and the consumptions, they are both useful tables in their own right. The ratings can tell you what the user thought of the movie, and the consumptions has information about the consumptions, the amount and when it happened. But it's also possible that you will be creating one of these middle tables for the sole purpose of joining those many-to-many. So books and genres. Books, each book can have many genres, right? Like Harry Potter is both children's literature and fantasy, you know. And genres can be associated with many books. Certainly Harry Potter is not the only children's literature book. So, and I can't, in my books table, I can't say that, you know, again, we get into this, you know, you can say author, title, and you don't want to say genre 1, genre 2, genre 3. That's messy and inefficient. But you can't in the genre table say book 1, book 2, book 3, also messy and inefficient. So the only real way to associate books with genres is to make a book genres table. And there you have a book genre ID, a book ID, and a genre ID. And then in this table now,
Generally, these first ID rows, genre ID,
yeah, so the primary keys most often are going to be auto-incremented integers. Sometimes they can be other things. Sometimes they can be, for example, if you're tracking employees, you just need them to be unique. So if you're tracking employees, they could be social security number, for example. Or if you're tracking books, they could be the ISBN number. That's a, you know, whatever, Library of Congress number, whatever you want for, you know, unique thing for a book. And then sometimes they are codes. And we could do that in our species table. Instead of a species ID, we could have a species code. And it wouldn't be the full species name, but it could be something like PD or GF, you know, and then, and that way, if you're looking at the prisoners table, it's a little bit more informative than just seeing species ID 1, species ID 2. But you don't have to allocate very much space for it. Okay. Yeah, so basically, so in book genres, then what we would have is we would have, you know, the book genre ID, the book ID, and the genre ID. And so the book genre ID, that's just unique to this row. The book ID, let's say that's Harry Potter. Harry Potter's book ID 1. And the genre ID is going to be children. So book ID 1 is Harry Potter. Book ID 2 is going to be Lord of the Rings. And then genre ID 1, and these would all be stored in the book and genre table. I'm just not writing out those full rows. Is going to be children's, and genre ID 2 is going to be fantasy. So here, fantasy, that's a whole different thing. Okay, so here we're associating Harry Potter with children's. We'll associate Harry Potter with fantasy. And then we'll also associate Lord of the Rings with fantasy. And in order to find out what genres Harry Potter belonged to, we have to do a join on this book genre table. And then, and we'd have to probably join to the genre table as well, so that we got like a nice genre name instead of just the ID. And then you have all of your information. But this is really the only way you can do a many-to-many without wasting space. Anytime we have a new association between a book and a genre, we just stick it in this table, and we rely on joins to get the information out. questions on one-to-one? Oh, yeah, well, I haven't talked about one-to-one yet, but questions on one-to-many or many-to-many?
So usually when you have a many, there's an additional, like when you're thinking about it ahead of time, that means that there's an additional table you have to create.
Always, for a many-to-many, there's an additional table. Like again, at Hackbright, we used to say many-to-many is a lie. There is no many-to-many relationship between two tables. There's just two one-to-many relationships to this middle table. There's no way in SQL to make an actual many-to-many relationship between two tables. You need that middle table, and you have two one-to-many relationships. Yeah.
The one-to-many, you're putting the ID on one side. You
put the ID on the one side. Exactly. So each cage can have many prisoners, but each prisoner can have only one cage. So it makes sense to have a cage ID associated with the prisoner.
I said earlier when you have a one-to-many, the idea of the many into the one.
Yeah, the ID of the many into the one. Oh, I may have misspoke when I said that. You want to put the ID, well, it depends. The many is kind of like a weird thing to say, but yeah. So, but if you, each cage can have many prisoners. Does that make cage the many, or does that make prisoner the many? I guess it makes prisoner the many. Anyway, the thing that can have only one of the other thing, that's the thing that gets the ID. But you know, like you can try and memorize that if you want, but you can more just reason it out, right? It's like, would it make sense to put the prisoner ID in the cages? Would it? Why not? Well, let's for example, let's say let's use something that's a little bit more intuitive. Species. I put the species ID in the prisoners. Could I have just put prisoners ID in the species table? Why can't I just do this? Here. Yeah, why not? Because each species has more than one prisoner, right? So I would have to do prisoner ID 1, prisoner ID 2, prisoner ID 3, and then I would have to constantly be adding columns to the table every time I got new prisoners, which is not how databases work. Columns are totally static. You can add as many rows as you want, but adding columns is a big deal. At a company I worked at, like I would want to add columns to make life easier for myself, but we're talking about tables that had millions and millions of rows. And adding a column is called a migration. You have to update every single one of those rows with the new column. And you have to do it during a time when people are not using the data, because and if you have a lot of rows, it's not instantaneous to do it. And you know, so it's a problem. Adding a column is a big deal. Adding a row, no big deal. Yeah. You want the number of rows to be flexible, but the number of columns to be completely static. Yeah. So if you're not sure where to add it, just think about, you know, like if I were to put prisoner ID here, would it be sufficient for each species to have one prisoner ID? No. Would it be sufficient for each prisoner to have one species ID? Yes. So that's the way to think about it. Okay. Let's talk a little bit about one-to-one. What are the one-to-one relationships in our dark crystal database? We have species, we have prisoners, cages, consumption, skeksis.
That's a question, and I was writing them. I was taking notes down.
Yeah. What are the one-to-one relationships? We don't have an essence table. In general, there are none, by the way, that's why you can't think of it. One-to-one is pretty rare. The use case for one-to-one is when a subset of one of your tables is going to need more information. So an example of that would be, let's say you have let's say your Twitter, and you have a table of Twitter users. And then you also have a table of Twitter employees. All of the employees are users. Employees are a subset of users. So this would be a one-to-one relationship where, I mean, every employee is only associated with one user, and each user is associated with at most one employee. But you have a different table because employees have a ton more information than users do, and you don't want every user to be carrying all those blank columns. One-to-one, rare. Something is a subset of something else. Yeah, one-to-many, many-to-many, you use all the time. Every non-trivial database is going to have some one-to-manys and some many-to-manys. But I'm honestly not sure if I've ever seen it out in industry, a one-to-one relationship at companies that I've worked for. Okay, cool. How would you like to use the last 10 minutes?
I was looking at this first documentation.
Uh-huh.
And on the schemas, they talked about something totally different. That's why I'm lost at what is up here and what is here.
Okay. Do you want to Slack me the what you're looking at? You can just Slack it to the phase 2 channel. So when you were talking about a schema, you were talking about something totally, you were not talking about data modeling at all.
I don't know. I thought it's kind of same thing.
Yeah. So schemas, okay, yeah. So I associate schemas with data modeling. Schemas you can also think of as a collection of tables, right? And so that's so when I think of creating a schema, I think of creating a collection of tables. Often, usually, databases have only one schema. So so I think of like creating a schema and creating a database as sort of the same thing. But here, Postgres has the capability of having databases that have separate schemas. It's one database, but you organize your tables into separate schemas. That's what this is talking about here. It's just a way of organizing tables, of grouping tables.
That's why I call it something like namespace and see like some users will have access to certain tables but not have access to others.
Yeah, you can definitely use it for for permissions. Yeah, where you can say, instead of granularly saying this user can read this table, read and write this table, and whatever, you can say they can read this group of tables, read and write this group of tables, and cannot even see this group of tables. Yeah. Huh. And then I guess you can make schemas that are just a username. Okay, that's fine. Yeah, I don't have a lot of experience with schemas, but yeah, organization and authorization.
Do you have any resources for understanding Postgres that are easier than the docs? Because for whatever reason, like the Postgres docs, among everything I've looked at it.
So resources for understanding Postgres other than the docs. What kind of understanding are you looking for?
I'm specifically looking for like working with Postgres in the command line.
Yeah, have you looked at SQL Zoo?
Those are just exercises or queries.
They are queries. Yeah. Oh, so you want, yeah. So the SQL Zoo is pretty much all I got. Yeah. So,
I sent another link, which I just found. There are some commands. I put it on page 2 about Postgres on command line. There are some help.
Okay. Oh, do you mean Postgres? Are you talking about like create DB and, oh, interesting. Okay. I mean, for as far as that goes, I'm just such a big proponent of like Postgres or pSQL help, right? And you're like, oh, these are the things you can do with pSQL, right? And you're like, oh, look at that. You can do a -L for list. Oh, those are all of my databases, right? And even if you're in the console, you can do a \# and it'll give you, all sorts of, or \h, and so it gives you all sorts of information that way. So I would recommend. And then as far as the Postgres commands, I think they're all just in user local bin. Do you guys know apropos? Apropos is give me all of the commands. This is a Unix tool. Give me all of the commands that include this in the description. So cool. Look at all of these commands that have Postgres, right? And then you can do the -- help, or you can do the man page on these. Yeah, apropos is fun. It's not a commonly used thing, especially now that there's the internet. But yeah, I started coding before the internet, and you actually needed to use apropos and man pages and all these other things if you actually wanted to get any information at all. Or you had to buy books. It's a whole new world out there now. Cool. Other questions? Great, because I really need to go to the bathroom. So
Thank you.
you're welcome.